When you have multiple links that get you to the same place, whether it is the internet or an internal network, you might want to set up what is known as failover. When one link goes down, router S can switch to another one automatically. And yes, also switch back to the first one when it comes back. There are, however, different ways how we can achieve this. You could go for advanced load balancing methods that are constantly redistributing traffic over the available links, but can make your configuration pretty complex and introduce potential pitfalls and unwanted side effects. So I recommend starting with a more basic failover setup first. Here I have this virtual setup with 2 internal connections and 2 respective gateways. Let's see how we can configure our router so that it does failover with these 2 ISPs. We already have the respective IP addresses pre-configured, and the only configuration we need to do will happen in the IP route section. You can see there are 2 dynamically created routes that simply tell the router through which physical interfaces can it reach the gateways. They are called directly attached routes, and they have this distance parameter set to 0. Distance is like a priority for routes. The lower the number, the higher the priority. We can use this to create 2 otherwise equivalent default routes, but prioritize one over the other. Then we can combine this with the built-in check gateway parameter to create a basic failover mechanism. The first route should send everything to the first gateway. It should have the check gateway set to ping, and distance can be set to 1. Then the second route goes to gateway 2, but doesn't really need the check gateway enabled. It just needs distance set to a higher number than the primary route. Now you can see that our primary default route has a letter A next to it, indicating that it is active, and the other route does not. If I ping some public IP address, it works, and disabling gateway 1 will result in a timeout at first, but then in a moment or 2, the secondary route will become active and the ping will work again. We can then enable the first gateway, and in a moment our router will activate the higher priority route. This is all great, but there is a major problem here. The check gateway parameter is pinging the gateway to determine if the connection is still valid. This will only work if the point of failure is either in the connection to the gateway or the gateway itself. If something goes wrong further on the ISP side, you will not know. To create failover with the perfect fault check, you could use our NetWatch tool, as it could let you ping some reliable public IP addresses. That's in fact how Internet Detect features usually work. They just ping some server that is always online. The NetWatch tool also lets you tweak several detection parameters, allowing for more snappy or more forgiving route switches. But this tool requires you to know basic scripting, so I'll not use it just now. Instead, we will remain in the route section and do a little hack using what is called recursive routing. First, we need to remove the primary default route and replace it with one that leads to nowhere other than Google itself. This looks funny, but bear with me. We need to add another property called target scope. I will set it to 15, and we want distance set to 1 again. Now our new route is immediately inactive. If the router was alive, it would probably think that I'm stupid. But fortunately it is not, and all it cares about is where is the next hop. Since we are not directly attached to Google or in the same broadcast domain as Google, the route is useless, but it can recursively lead to another route. Let's add a route with destination being Google DNS and gateway none other than our primary gateway number 1. And we want to set the scope to 10. It just needs to be a lower number than the target scope for the other default route, so that recursive routing can take place. Now, if we check the routes again, our Google default route is active along with the recursive route. The router is performing the ping gateway check against Google DNS, but routing everything through the correct gateway. Gateway 1 doesn't know or care why it is the next hop for your router. It just receives the packets, looks at their destination addresses, and processes them further as usual. So this is one simple hack how you can set up failover for your internet connection with just 3 lines of route configuration. You might still need to make firewall changes and set up masquerade for both ISPs, but that is a separate topic. In this case, we use the Google DNS address, but you could use any other public IP you like. And of course, you could also set up more than one default routes leading to Gateway 1, so that if Google DNS is down, you still check Cloudflare DNS before you switch over to Gateway number 2. Alright, thank you for watching, and I'll see you in another one.